So we're going to do a couple of days now of factoring polynomials. We've learned the skill of dividing, which is what factoring is. If you think about even just factoring like a quadratic from grade 10, you did a lot of that in grade 10 and grade 11. You know, you're really breaking it up. Like if I take 12 and I factor it, 3 times 4, right? I'm just dividing. 12 divided by 4 gives me the 3. 3 and the 4 are my factors, right? So it's the same process, we're just dividing. In that case, we're looking for perfect factors, so no remainder, right? The skill of dividing polynomials that we did yesterday sometimes ended in a remainder. That's fine for that skill because we need to know how to divide in order to factor. But when we're factoring, you can't have a remainder. We want to have a properly, perfectly factored polynomial like we saw in grade 10 and 11 for quadratics. So that's where remainder theorem comes into play. So remainder theorem just says that if the function f of x is divided by x minus a, so that could be x minus 2, or it could be x plus 2, right? And then a is negative 2. The remainder is f at a. So what does that look like? Okay, let's take a look. For the function f at x equals 2x to the 4th plus 5x cubed minus 29x squared minus 38x plus 120, determine the remainder of each divisor. So for this one, my a would be negative 1. So if I want to know the remainder, I just calculate a at negative 1. Sorry, f at a, which is negative 1. So we're going to try, yes.
Why is a negative 1?
Because that's what remainder theorem says. So it's x plus 1 is what I'm dividing by, but it's x minus a. It's the same reason when you are solving a quadratic equation. Okay, so if I do something like this, x squared plus 7x plus 12 equals 0. And that factors to x plus 3, x plus 4 equals 0. So x equals negative 3 and x equals negative 4, right? It's the same reason. It's kind of the same reason why the shifts, the horizontal shifts, are backwards, right? It's all of those ideas, all those concepts are related. They're all basically the same thing. They're all results of the same mathematics. Okay, so you certainly flip the sign. You put that in. And we're going to streamline this process. In fact, most of the time you can probably just do it on your calculator. So negative 1 to the 4th is positive 1 times 2 is 2. Negative 1 to the 3rd is negative 1 times 5 is minus 5. Negative 1 squared is positive, so this is going to be minus 29, and then plus 38 plus 120. Use my calculator. I got 126. So my remainder is 126. This means if I did the division, if I divided x plus 1 into f at x, that's what I would have found as my remainder. That's what remainder theorem says. If all you need to know is the remainder, you can just find the value of the function at that point. Okay, so you can try the next one. A little bit harder with a 2 because you have to actually, like 2 to the 4 is 16, so you have to do some multiplication. Don't forget to change the sign, so it should be positive 2.